Gradient vector is what? Sorry.
Gradient vector is very useful. See, gradient
Yeah.
vector.
Yeah.
Gradient vector is denoted by inverted triangle. Okay.
Yes.
Its value is del by del x, del by del y, del by del z. Okay.
Okay. So derivation of multiple variables.
Yes.
Which means like we are trying to find the tangent or the slope for different lines or for the
For
line in a
different
different.
vector. Yes.
Yeah. Okay.
Okay. Suppose there is a function. This is what is scalar function because there is no ijk.
Because there is no what? Sorry.
ijk.
Okay.
Okay. Or you
Mhm.
can say whenever a scalar function is there, you can convert into vector function. How? By finding gradient. Okay. So gradient is what?
Sorry. I'm sorry. Can I ask like a simple question, please?
Yes.
So when we say a scalar function and vector function, what's the difference? Sorry, can you please remind me?
See, this is a scalar function. Let's suppose this is 5, x, y, z. There is no ijk. And this is a vector function. Let's suppose this is x square I, y square j, z square k.
And IJK are the coefficients.
Ijk represents position vector of x, y, z.
I see.
You tell me this is 2 and this is 2i, 3j plus
Hmm.
4k. What is difference between this and this?
Yeah, there is a difference,
Yes.
definitely.
This
Two
is
is a
scalar
scalar.
vector. Yes. And
And
this is
yeah.
vector. And you know vector is
Hmm.
also represented in this way. 2, comma 3, comma 4.
Right.
Right. So this is a vector quantity. Okay.
Hmm.
This is a scalar quantity because this is not
I
represented in bracket or like this. Okay.
see.
Anything which contains I, j or k, you can say that is vector.
Vector, okay.
Okay. So this is a scalar quantity. I want to change this into vector form. How can you change? Just multiply with gradient vector. Okay.
Hmm.
When you open the bracket, you will get what? Comma.
Okay, so basically we are distributing
Yes.
the function on the okay.
Yes. You can differentiate with respect to x. So when you
This is
differentiate
the
with
first
respect to
equation, yeah.
yes, you will get 2x y square z square. You will get here x square 2y z square, right?
Hmm.
2z x square y z, right? This is your
Right.
now this you can also write 2x y square z square I 2x square z square j, right? Because this is second component and third component is k.
Right.
Okay.
Yes.
Yeah. Okay. So
Yeah.
whenever you want
You
to
know,
change,
you are answering. Sorry for interruption. You're answering a lot of questions in my mind because I used to see these things, but I didn't know how to differentiate between them. What does it mean, scalar function and vector function? Yeah. Thank you.
a scalar function is a function which does not contain ijk
Yeah.
component,
Yeah.
and
Clear.
this is a
Now clear.
vector
Yeah.
function. Yes,
Thank you.
this is a scalar function, and this is scalar value. Why we say this function? Because this is expressed in a variable, and this is a constant.
Yeah.
This is
Hmm.
this is vector function. Why? Because vector is represented in terms of variables. And this is vector value.
Value.
Yeah. Okay.
Yes.
Okay. So sometime, let's suppose this is f. Let's suppose this is a function f. Okay. So you can also write here what? Fx, fy, fz. Fx means what? Differentiate f partially with respect to x. Right? This is
Yeah.
f. When you open the bracket, you are getting what? Del f by del x, right? Del
Yeah.
f by del y and del f by del z. In short form, you can write fx, comma, fy, comma, fz. Right? And you got this. Okay.
Yes.
Okay. See, find grade f at 1, 1, 1 for f is equal to function can be anything. Okay. Okay. Here function is what?
Find the gradient for, okay.
And you know how to find grade f? Grade f is basically what? So you can write f of x, f of y, f of z, right? So I am finding here f of x. F of x means what? Del f over del x.
Yeah, the derivation to yeah, in respect to x. Yeah.
So you will get a yz cube. Find f of y.
So how can you incorporate that vector that you put there? 1, 1, 1, 1.
I tell you. First find this. So 3x yz square, right? Put here.
Yeah.
Fx is what? Yz cube, xz cube, 3xyz square, right? Okay. Now at point 1, 1, 1, you can write 1, 1, 1. Okay. So put the value of x is equal to 1, y is equal to 1, and z is equal to 1. What you will
I
get?
see.
When you put 1 here, you will get 1 into 1 cube. 1 into 1 cube. 1 into 1 into 1 square. So 3. So 1 comma 1 comma 3. Right?
I see.
Okay.
Which means like the function
Which means,
is increasing.
yes, which means the function at point 111 has result 113. It means the slope of this function at 111 is 113.
3. Okay.
Okay. This is basically what? This is a slope actually.
Hyper. This the result will be like hyperplane, right?
Yeah.
Hyperplane.
This is hyperplane. Hyperplane have more than 3 dimensions. This is a 3D.
3D. Okay.
Yes. Okay. You can
Yeah.
say the hyperplane, but there is a name for when 3 variables are there. You can say 3D, three, di-
3D.
dimensions. Yes.
Okay.
Understood? You can go through one.
Yes. Yeah. Okay. We do the derivation in respect to x, then y, then z for the sum function. We gather them in one vector here, and we compensate the vector 1, 1, 1, or whatever any vector to check the value, and the result will be the slope on that specific. It's clear. Thank you.
Yes. Okay, done. This is same thing. Now see what is directional derivative. How to find directional derivative? So you can see directional derivative of vector u. Directional derivative of function f in the direction of u is what? Grad f
Equation of F. Mhm.
dot
With respect to
unit vector of u. What
I
is
see.
this? Suppose there is a function and you want to find directional derivative. Directional derivative means what? The plane is perpendicular to this function. So first
Mhm.
I will change the function into vector, then find its normal vector. You will get this. Okay. Okay. If I ask to find there is question actually. See this question. See, function is what? Okay. First you tell me what is level curve. I already told you how to find level curve, right? You know how to find level curve? Yes. How to find level curve? For level curve, put x value, y value. First put 0, 0. When you put 0, you will get root 9, right?
Mhm.
Root
Yes.
9 is what?
3.
C. No. For level curve, put the value of f. Let's suppose f is 0. If put f is equal to 0, you will get what? X square plus y square is equal to 9, right?
Yes.
It means you will get a circle, right? Of radius 3.
Right.
Now put f is equal to 1. Let's suppose you are putting 16. Then what will you get? X square plus y square is equal to 4, right?
It's gonna be bigger circle. Yes.
Yes. So when you increase the value of f, you will get a circle, right?
Yes.
And when you combine this all this curve, what will you get? When you combine this, you will get a cylinder. actually.
Oh,
Okay. Okay.
the
So
3D. Okay, the
yes,
volume.
yes. So okay, this is a
Yeah.
level curve. Okay. The bigger value you will put the value of f, the bigger size you will get, right? This is a
Mhm.
level curve. Understood?
Yes.
Okay. What direction does f1 comma 2 is there? So first we find del f, grade f. Grade f is basically what? Fx comma fy, right?
Right. Yes.
So
Because we
first
have to
we
values.
find fx. Fx is what? Derivate with respect to x. How will you derivate this?
So we can say this function, maybe simplify it a little bit, saying like 9 minus x squared minus y squared to the power of half.
So yes, it will be root x is 1 by 2 root x square minus 2x, right?
And yes.
Okay. Now find y. Same thing, right?
Mm-hmm.
So grade f will be what? Okay. Now at point 1 comma 2, put the value of x is equal to 1 and y is equal to 2. When you put, you will get 9 minus 1, 8, 8 minus 4, 4, right?
Yes. And
So minus 1 over 2, comma, minus 1 over 2. Both are negative. Both are negative means,
going down.
yes. So actually,
Down after that.
yes, yes, yes. It means that the level curve not going upside, it will go downside. Okay, like this.
Yeah,
Okay,
exactly.
yes. Because when you put the value of f greater than 9, you will get a negative. It will not exist. You can check here. Suppose I am putting 16. So x square plus y square 9 minus 16, which is not possible, right?
Yeah.
So square of anything
But
cannot
yeah,
give negative value.
negative.
It means
Yeah.
that you have to put less than 9, right? When you put
Yes.
f value less than 9, then you will get the exact value. It means the level curve is going down inside, right?
Yes.
Yes. Understood?
Yes. I
Okay.
get.
Now see, calculate directional. This is what? This represent directional derivative. Without calculate du and f du. So you know how to find this? You have already what? 1 comma 2 and vector u it is given. Okay. So you know grade f, sorry, directional derivative of u for vector 1 comma 2 will be what? What is the formula? Grade f dot vector u, right?
Mm-hmm.
Dot product zero point 0.6 comma minus zero point 0.8. 0.6 into minus half is what?
minus
Point
0.3.
three, and this is minus minus plus 0.4,
Yeah.
0.1. It means that the distance from normal vector f to unit vector u is 0.1. Okay, this is called
See.
directional derivative. Understood?
Yes. A little bit confusing, but I think I understood. Yeah.
What confusion? Tell me.
So started to mix between direction uh the derivative and the directional derivative. I mean uh we
See,
find another distance here.
directional
Yeah.
derivative means suppose there is a function f. So first find the normal vector of f. Okay, you already
Okay.
find, yes, normal vector in the previous class.
Yes.
So what is the distance between normal vector and this vector? This vector means vector u. That is called directional derivative of f in the direction of u.
I see.
Okay, this is not normal displacement. This, you can say, what is distance between the normal vector of f to the other vector u.
Okay.
Okay,
Yes.
yeah, already find. Oh, 1 minute. I did some mistake. Actually, minus 2 by 2 is 1 here, right? So 1 will be there. So 0.5 will be there, right?
I see.
Yes. See, I tell you, 1 minute. See, suppose a function f at 3 comma 7 is 12. Okay. And suppose another function, same function at point 7 comma 4 is 10. What is distance between?
Between the two vectors.
Yes.
So we need to find the derivation, right? The gradient descent of the function.
See, distance between two vectors. So how can you find 7 comma 4 minus 3 comma 7? One point is what? 3 comma 7. This is 3, this is 7. And second is 7 comma 4. So what is distance between these?
Between 2 points,
Yes.
it's the root square of x, root of x y2 minus 1 y minus y1 square plus x2 minus x1 square, right?
But this is a function actually, not a at 2 point. Yes, you can find using these 2 points, right?
Mm-hmm.
Yes. By formula, 7 minus 3, 4 square, and this is 3 square, 5 unit distance, right? Okay.
But how did you select 4 and 3 here? Sorry.
I did not select, I do difference. 7 minus 3 is 4.
Oh, I see.
4 minus 7 is negative 3,
Oh, yeah.
right?
Okay.
Distance between 2 point,
Yeah.
yes. Okay.
Which is the difference between the x and, yeah, difference between y square and the root. Yeah.
Yes. Now you have to find the rate of change traveling towards 7 point. So rate of change
The rate
means
of change. Mm-hmm.
average. So let's suppose this is
Yeah.
denoted by delta t. This is what? F734.
Difference between, yeah, between y over x, right?
Yes.
Yeah.
And this is what? Okay.
Mm-hmm.
At 7 4, this is 10. Yeah. Upon 7 minus 3. 4. Right?
Mm-hmm.
This is absolute value.
Right.
And this is minus 3 absolute value. You know how to find absolute value?
Yeah. Change the,
4 square minus 3 square. But distance is never negative, so you can write 2 over 5. This is the rate of change.
but but the rate of change,
Yes.
it can have uh what I mean, like, can be positive or negative, right? Which means like increasing or decreasing.
Yeah. Rate of change is decreasing.
Yeah.
Right. It means that the rate of change is negative. It means that function is decreasing, and you
Yeah.
can see, yes, you can see here.
Yeah. Yeah. That makes sense. Yep.
Yes.
Okay.
Right. Now,
Right.
can you try this?
Okay. Suppose we have G 02 equal 15 and G 41 equals 17.
Hmm.
What's the distance between them? It's gonna be like this, the same as above, to 0 minus 4 square plus 2 minus 1, which equal 1 square. It's gonna be 20 4 square 16 plus 1 17 square root of 17.
Hmm.
This is the distance between them, right?
Yes.
So and we can after that find what's the distance, then approximate the rate of change of G at 0 to traveling toward.
So distance between this is 5.
Okay.
How? 4 minus 0 square? No, no,
Mhm.
not minus 5. 1 minus 10. 16 plus root 17.
17 square root of 17, yeah.
Yes. And you can see one point is 0 comma 2 here and 4 comma 1 here. So this is also negative.
Yes.
You can check. 17
Approximate
minus.
rate of change of G 0 to traveling to core 1. Okay, yeah. Yeah.
0 to 2. Okay.
17 minus 15, that's right. Over the
Mm, 4 minus 0.
but yeah.
1 minus 2. Root 20. One over root 5.
Okay. Here it should be minus in any shape or form. Shouldn't be positive, right?
Mm. Okay. So it should be minus, right?
Yeah.
0, comma 2 lies here. And 4, comma 1.
So minus 15 or the distance between 2 points. Distance is square root of 4 minus
Mm. It is not important that function goes
might
in
be
this.
a type of the question
Yes,
itself.
yeah. Function may be anything. This is another function. The graph of this function may be anything, right? It can be this graph also. Any type of function, graph
Yeah,
can be there, right?
yeah, yeah.
Its rate of change is positive. It means that graph looks like this for positive, है ना? See, looks like this.
Mhm.
Any because gx is any function. Okay.
Yeah.
Okay. Now we find the gradient.
So the function is x squared sine
This is what fx
x
fy.
e. Yeah,
So first we find
that's right.
fx.
And one question before we go further this function. So we are assuming here our assumption that our system has like two variables only, right?
Yes.
But assume like we have 3 4 different variables.
Yeah,
We do that.
any variable. Okay. If it
Yeah,
contains three variable, you can add here.
yeah, I got it. Okay, thank you.
Okay. So now you can say here you will do using partial product rule. So
Yeah,
derivation of x square, derivation of what? Derivation. You know product rule?
yeah, yeah.
Derivation minus cos v into ey. This is 2x. Derivation of x square is 2x. Okay. Now find f of y. Right? X
Mm-hmm.
square is constant. Derivation of sin is cos into ey. Right? Put here.
Yes,
So fx is what?
x squared.
Sign a comma. Py cos xy, right? This is variable. Understood?
Yes.
Okay. You can go through once.
Yeah. Let me go through it. So f of x to x square sine x to the power y f of we are deriving just that. So
Okay. Right?
yes.
Yes.
Yeah, can you keep it please for 1 minute now?
Okay.
No, keep it, please.
See this. I think you understand this, right?
Yeah.
See this question. Question number 17. If fs is this, find the unit vector that maximize for this value. Okay. See, this is basically what? Directional derivative?
Yeah.
Okay. So you know how to find directional derivative? The left vector u, right?
Yes.
Okay. So first we find grade f. Grade f is what? Fx f of y. Fx is 3y. See, there are three variables. So you have to also write f of z.
Is it right?
F of x is what? 3y. F of y is what? 3x. F of z is 2z. Okay.
Okay.
Okay. So at point 21 minus 1. So when you put y is equal to 1, 6 minus 8. Right?
Mhm.
Okay. So right here.
So where's the unit vector here?
Unit vector means what? Whenever, let's suppose this is a vector
Uh-huh.
A, B, C.
Okay.
If this is unit vector, then its modulus is always 1.
Yes. Okay.
Okay. So
Yes.
3, 6 minus 8 dot, let's suppose this is ABC. Okay. So you will get 3A, 6B minus 8C.
Okay.
Okay. If this is unit vector, then its modulus is what? 1. Then you can say
Yes.
their absolute value is 1, right?
Yes.
Okay. And finally that maximize. Maximize means what? The maximum value of unit vector is same as 1. Okay. You can say maximum value of directional derivative is mod f. Okay. So what is the absolute value of mod f? 3 square, 6 square plus 8 square. 190 you are getting, right?
Mhm.
So the value of this will be what? 109. Root 109. Okay.
Yes.
Okay. Now you have two things. What? 1, 3a plus 6b minus 8c is equal to 109. And second thing is a square plus b square plus c square is equal to 1. Okay.
Yeah. Two different equations for
Yes.
three variables.
But this is very tricky to solve this because this is in square and this is in normal method.
So yeah. So yeah, that's
Yes. But you understand now what is how to find a gradient and a distance, right?
yes. Yeah. That yeah.
10 you try 19? 19 or 20, anyone?
So we have the unit vector 2/3 minus 1/3 minus 2/3, and that x is x e to the power yz.
Hmm.
Compute the directional 304. So you have to find the derivation first for each variable, right? So we derive by x, then y, then z.
Okay, this is u. Fx will be eyz. Fy will be right.
Yeah.
So put y is equal to 0. When you put y is equal to 0, e raised to 0 is 1, right?
Yeah.
Okay. And you know how to find this? Right?
Yeah, it's the multiplication of these, which will be like little products here, right?
Hmm.
Yeah, little.
Yes, minus 12 over 3.
So we come up with one scalar value here for
Yes, you will get,
yes,
yes, you will get always a scalar value.
I see.
Okay. Go through once and try 20.
Yeah.
Yeah.
So first we found the derivation
Yes.
per
Fx,
variable.
Fy, and Z. Yes.
Yeah. Yeah, I think like
Right?
yeah, thank you.
Now see question number 21.
21 says like we have
This is a,
u is a
yes, this is vector u, 2, 3. But this is not unit vector, this is normal vector. So first we find unit vector. How you find unit vector? 2 square plus 3 square is what? So unit vector is what? Right?
mm,
Okay.
okay.
Now find fx. Find fy. Okay. At minus 1, 4. When you put minus 1, you will get minus 2 plus 12. Can minus 3, right?
Yeah, which is the multiplication of u by f.
Right? This is your answer.
Yeah.
Understood? First, we find unit vector of U. You can go through one.
Yeah.
And in this question, it is already given a unit vector. Because when you find the modulus, you will get 1. You can see. Okay.
I see.
49 by 49. So 1. This is already given in unit vector form, but this is not given in unit vector.
Yeah.
Okay. So whenever,
Yeah. I see the difference.
yes, whenever U is not given in unit vector, always divide by its modulus. Okay.
Always divide by what? Sorry.
Always divide by its modulus.
Okay. Yeah.
Modulus means absolute value. Okay.
Yes. Yeah.
A is not a unit vector, but you can make it unit vector. How? Divide by its modulus. Okay.
And the modulus is going to be the square root of
Yes. Let's
AX.
suppose yes. A1, A2, A3. Modulus will be A1 square, A2 square, A3 square, right? Understood?
Yeah. Okay.
The same question. See this figure.